Welcome. Today we're going to do a talk on versions and all the versioning bits and pieces that's available to you with Terraform. So there's the Terraform binary itself. You have the providers that Terraform provides, and also the modules. And so we're going to journey from the very beginning to the end and take you along all the versioning bits and the upgrades. Hopefully you can muster some courage and we'll get through everything. Today you'll be listening to me, Brian. You can find me on social media. I'm available at Twitter, LinkedIn, and GitHub. And you can find me by my last name and first initial. Of course, you're always welcome to contact me and reach out. I can help where it is that I can. And there are a couple of public community Slacks that I'm on, like Google's and such. And I'd like to introduce to you with me Nick.
So hi, I'm Nick Jackson. I'm a developer advocate at HashiCorp. Again, you can find me across the internet in a bunch of different places, on the HashiCorp forum, CNCF Slack, and well, you know, I'm sure you can find me somewhere, anywhere.
Naturally, I work for Anaplan, so it would be wise of me to welcome you to come join me in my career and help us build great things. So here at Anaplan, we do corporate and business planning, and so we would love to grow our engineering organization and bring some better products and innovate in the industry. So take a look at the careers link, and you can kind of find up open engineering jobs and other areas. So at the beginning of our journey, we need to talk about semver. Now, semver is your semantic versioning, and that has a couple of constraints. So you have the major, the minor, and the patch, and then you have the syntax that comes along with that. And so with the syntax, you have some exclusive syntax and you have some inclusive syntax. Now that exclusive means that the version that you indicate is not included by virtue of being excluded. Inclusive is, I want to begin with this version and include it and either go greater than, less than, or be exactly equal. What's special is minimum specification, which is tilde greater. Tilde greater allows you flexibility with your versioning. So it allows you to say 0.12.0, and when you use tilde greater, that allows you to have all 0.12. whatever patch versions. So if there is an update to that patch, because you've specified 3 segments, you can get anything from .0 in that patch all the way forward. And this works for every segment. So if you do 0.12, that'll include all 0.12 and higher, so 13, 14, and so on. And so we'll get further into that, and you'll see that theme constantly present. So let's begin. At the very beginning, we talk about Terraform versions and the binary and how that is. But let's recount a little bit of the history along with that. And I could think of no better person than Nick to recount that for you.
Cheers, Brian. So Terraform versions. Let's go on like a history, an archaeological tour of Terraform back from the very beginning in July 2014, right the way to this summer when 1.0 came out. So at the beginning, Terraform was released 0.1. July 2014, it was released with limited number of providers, AWS, DigitalOcean, predominantly to kind of like show how the kind of the system worked, how you could use Terraform and to enable people to kind of start building into the ecosystem. Now, I'm going to skip a few years because ultimately when we kind of looked at the beginning of Terraform, it was a lot of provider development, it was a lot of kind of sort of features and interpolation functions and things like that. But the real sort of important changes started to happen when we started to get like stability, if you would, I suppose, but you know, more sort of commonality in the use. It became more popular, and in 2007 we introduced data sources. So data sources was a major change in the way that Terraform worked, because a data source now allowed you to be able to read a piece of infrastructure or the properties of a piece of infrastructure, as well as being able to create them with your resources. So this allowed you to kind of build richer and more dynamic Terraform configuration. Now, shortly after that, and kind of coming it to the end of 2016, we released 08. So Brian's going to talk about this, but 08 was when the Terraform block was released and when the version parameter was also introduced. This is when you could start to say that, hey, This Terraform configuration is associated with a specific version of Terraform. And that was really needed because we were kind of adding a lot of features and changing the system very, very quickly and quite often throughout the years. Now, 0.9 came in the middle of somewhere around 2017. 0.9 was an important release because what that brought was state locking. The ability to collaborate on Terraform configuration. You had the ability to store Terraform state remotely in things like S3 buckets, but now you had the ability to lock that state. It allowed multiple people to collaborate on the same Terraform workflow. And previously this was only possible if you were using Terraform Enterprise or something sort of third party like Vagrant, things like that. 0.10 was a really important release because with 0.10 what happened was we started to distribute the binaries for the providers independently of Terraform. Now why that was important was that Terraform was growing at a pretty sort of astonishing rate. And I think around about this time we were running around 70 providers. So, you know, in sort of 3.5 years, we came along and added sort of another 70 providers. Now, when we were distributing the provider as part of the Terraform binary, if a change was made to, say, the AWS provider, you had to release Terraform. Now, that's not sustainable, and it didn't sort of create a good community workflow either. So we started to break this down. The binaries became independent, the providers could have their own release cadence, and Terraform could have its own release cadence. In 0.11, and this was kind of around, well, it was actually at HashiConf in Austin, Texas, I believe, we released the module registry. So now with Terraform, you'd been able to kind of build modules for a while, but we wanted a way to enable the community to easily share those, to be able to kind of distribute those, and importantly, as we will kind of look at later on, version modules. 0.11 was kind of a step towards something which is a lot of people in the community would say was a big change, which was 0.12. So 0.12 was the introduction of HCL2. And in the summer of kind of 2018, what we did was we started to talk about 0.12. We released a series of preview blogs where we talked about the new language features, why the language features were needed in order to be able to kind of push Terraform forward and to be able to get to that sort of situation where we can say it's now language complete or near language complete and there'll be no more breaking changes. But it was a lot of work. So that blog post stated, hey, we're going to release Terraform 0.12 with HCL2, which very sort of big language changes, in Q1 2019. Now the work for HCL2 actually started about 6 months prior to that blog post. And by the time we actually released it, which was around about summer sort of 2019, there'd been about a 2-year period of working around HCL2, the new interpolation features, the new language features, and some of the sort of the dynamic blocks that the community had been asking for. It was a huge undertaking by the sort of the Terraform team, and it was a huge undertaking by the community as well, because there was obviously an introduction of changes which you had to change your configuration for. Now, 0.12.18, we released it was just a minor release. So we're kind of still iterating, but 0.12.18, we started releasing binaries which are signed for Mac platforms. We're kind of making sure that the Terraform environment is working in the way that it should be on the developers' computers. And 0.13 was a kind of a big release. 0.13 came, the beginning sort of 2020. Now with 0.13, we took that provider ecosystem and we did what we did with the modules, with the registry. So we enabled providers which were written by the community to be distributed and to be socialized through the Terraform registry. So you can, again, now find providers for various different solutions and tools out there, and Terraform can download those and it can sort of import those automatically as the separate binaries. 14, again, we're still moving and marching towards this 1.0 release, iteratively, little by little. 0.14 introduced a big change, which was around state. We introduced code into Terraform, which enabled Terraform to be able to read different state files. Now, previously, this was kind of a bit of a sticking point, but from 0.14, Terraform could actually read a huge number of state files, which gave it more sort of backward compatibility and more forward compatibility as well. Now, where we were kind of going with this, and the state file hasn't necessarily changed, it's still on version 4, but we wanted to get that 1.0, that compatibility promise. 0.15. Now, 0.15 came, and 0.15 introduced some more breaking changes. So we kind of removed the quoted variable constraint. So, you know, if you were defining a variable type as string, you now didn't put quotes around it. We changed some of the interpolation functions. So you've got list and map became toList and toMap. These, we hoped, would be the very last kind of breaking changes in the language before we would get to 1.0. And this summer, 1.0. We finally got there. And the thing about 1.0 for us, again, it wasn't about production readiness. Terraform's been production ready and used in production back since that original version back in 2014. But it was about the compatibility promise. With version 1.0, we were kind of making the statement to the community that we are not going to make any more breaking changes to the core language. We weren't going to change any of the core workflow features. So things like init and apply and plan, you know, core workflow features like that would remain the same throughout the 1.0 life cycle. So if you're using 1.10, it will work just fine with 1.0 configuration. If you've written CI/CDs setup for version 1.0, that should work fine with 1.10. And that compatibility promise we're going to make throughout the 1.0 release, approximately 18 months, we believe, but who knows what's going to come with Terraform 2.0. But Brian's going to show us actually just how you can use that Terraform version and dig into that in a little bit more depth.
Thank you, Nick, for the long journey down the yellow brick road of Terraform and all of its many stops along the way and the massive development that's incurred over the last 7 years. So let's get a little bit into some of the specifics. As referenced before, the Terraform state file is predominantly where Terraform version kind of came in, was introduced, and tells you what version of that binary generated all of this content. So this is a small snippet of what some of that is, and it'll tell you exactly what that binary was. Grabbed a little bit older of a state file because there's been a number of different versions, as Nick referred to. As of latest, we're up to version 4 now. Over 7 years of development, that's a very good track record as far as version incrementation and stability in that. Naturally, with the advent of Terraform 1.0, now you have the ability of 1. Minor version to be able to support all the state files that are generated for that version 4 for those binaries. So if you do run into a situation where 1.1 and 1.2 are operating on the same state file, that compatibility promise now is there for you, whereas previously it was not. For the Terraform block, this came in at about 11.4 or 0.11.4. What this allowed to do is in the code, you can directly tell the person who's running your plan or your module what your minimum version spec or what your version spec requirement is for this sort of code. And so now you can actually see it in the code instead of going into the state file and trolling through and trying to find what it is that was compatible with and whatnot. Now, with Terraform version in the binary, you have a couple of options in order to maintain your plan and working and running and operating. One of those options is TFenv. TFenv uses a .terraform-version file, and you can see some syntax there that kind of allows you some leeway in what are my compatible versions so that when a user comes in, they can do TFenv, get the version that is for your plan even without having to look at the code, and start to run right away. Another option, which I've used both, is tfswitch. tfswitch tries to intelligently read your code and also grab that Terraform block and infer what kind of compatible version you need. It's much better, in my opinion, to try and read your code, but in the case of like Terraform Cloud or Terraform Enterprise, those workspaces explicitly cover or are configured for your version that you're going to run or execute. So those will be exact versions. So depending on your need, and of course you're in a much better shape if you've migrated up to Terraform 1.0 in order to run a multitude of different versions. So let's take a look at a little bit of the example and syntax. So before version 13, so again, remember your semver, we didn't include version 13. So everything up to version 13, you could configure the version directly in the provider. In fact, this was the only way before even version 12, is that you had a version meta argument and that semver syntax that allowed you to specify which version of that provider. Introduced at .12, now you have the Terraform block. Now the Terraform block has been there for a little while, but now we have required providers. And we have a key value pairing between those two. So you have the provider that you're going to initiate and that version. Now you no longer need that version matching into your provider's configuration, which would be like the top example. Now when we got to 13 and beyond, we discovered a need to kind of namespace that provider, because the community needed a way to push their providers into the ecosystem, and HashiCorp, of course, had to provide theirs. So for the ones that HashiCorp maintains, you'll see the default or assumed namespace of HashiCorp. And then for any other provider, say like for Rundeck, you'll see Rundeck/Rundeck, because Rundeck, the provider team, provides the provider for Rundeck. And then you still had that version nomenclature, but now we had to break that out between source and version. What was interesting is that while some of the syntax was still supported and introduced in 0.12.26, the source namespace was always assumed to be HashiCorp. It wasn't until 0.13.0 that we actually got to see other namespaces exist and other community providers start to interject their custom provider for all their things. And now the ecosystem is just absolutely massive in the number of things that it is that you can interact with and control with Terraform code. Now, with supporting these, you of course have to maintain or watch, or you do want to keep up to date. So there's the Terraform registry, as referred to earlier, and also there's an API. So if you want to take control of things and write things like webhooks or whatnot, you can check with the registry's API to see, hey, my code depends on these sorts of things. And your CI and CD pipeline can actually integrate that directly. You can, of course, follow the change logs at their public GitHub publishing locations. So like, for instance, AWS, Google, and many of the providers, especially the much larger ones, are on github.com. And you can track their changelog or just be notified on their releases. There's also Dependabot, which is right now still beta support for Terraform. And what it does is it tries to read your code and infer what kind of things that it is that you can benefit from. So if your code says, I want to use the AWS provider 3.54.0, and there's an updated release, and they go to 3.55, then the Dependabot will automatically open a PR for your GitHub repo and say, hey, I found a new version when I checked. Would you like to accept this PR? And you can track it and keep it automatic and up to date. Now, this can be important, but I'd like to let Nick explain a little bit in more detail as to why that's more important.
So it's incredibly important to keep your providers up to date. So the HashiCorp Compatibility Promise 1.0, what we want to do is we want to say no changes to the language, but the providers are iterating separately. Now, there's a number of reasons that a provider will have to change. It could be a new resource which is added. It could be deprecated parameters in a resource. It can be bug fixes. It could be the deprecation of a resource itself, or it could be a change of an underlying sort of API. So when you think about your provider, for example, if you've got infrastructure code, let's say you've got something which doesn't change very often. It's your core platform. Maybe you only touch it every couple of months. You want to still be kind of iterating over that configuration and making sure that the provider is as close to edge as you're comfortable with. And the reason you want to do that is because you want to know that that configuration still works. And if there are any changes needed, you need to change a parameter or something like that in a resource, do it before it's urgent to do so. What do I mean? Well, what I mean is that the phone rings and it's the middle of the night and something's gone horribly wrong and you need to rebuild your infrastructure. The last thing you want to be doing is dealing with updating Terraform configuration or any infrastructure as code configuration at that point in time. So get into the good practice. You could have a nightly plan which does a sanity check, or you could just kind of have a calendar entry to kind of keep it up to date, or use some of the tools that Brian's talked about. Depend upon a really good one there. But try and keep it as close to edge as possible. Make sure that you're always running a compatible provider that's compatible with the cloud APIs and things like that, so that when you need to make those changes, you don't have any problems and you can absolutely do so.
So yeah, with those registry providers that are up at the Terraform registry, also if you track there, one of the feature requests that I've asked for is to also be notified from Terraform's registry site, registry Terraform, so that you can see changes there. So just like you can follow on GitHub, we've requested the feature up there, and we can hope that that'll be accepted someday soon. So let's bring it up to the end of the road here and go through module versioning. Now, modules are going to be largely your code, and so it's about the user's impression of that version. And so let's recount and go back to our timeline and archaeology, and I'll give you to Nick.
Modules are an incredibly important feature of Terraform. One of the things that I genuinely love, and I think it was like 0.4 or something like that where modules were initially released. It was very early on in the sort of the development of Terraform as a tool. But what a module allows you to do is it allows you to kind of encapsulate something like a VPC, which contains multiple resources in a single unit. And of course, you can go bigger or smaller. That's entirely up to you. But in terms of like how modules have progressed throughout Terraform's history, there kind of were a couple of big events. I think the biggest event was probably the module registry. The ability to kind of version modules prior to the module registry was possible. You could add, for example, if you're running GitHub or Git, you could add a ref tag. And the ref could be a tag, it could be a commit hash or something like that. But with the module registry, we added a specific sort of version tag. And the version tag allowed you to employ some of the sort of the semver constraints that Brian talked about earlier on in the talk. The ability to kind of say, I want greater than this version or less than that version. And that's kind of like a big step forward in the flexibility of how you're going to deal with modules. For me, I honestly think that modules, and the most important part of modules, was the introduction of count. And I think there's many people in the community who will agree with me that count is something that you've all wanted in modules for a little while. And to kind of give you a sort of little history on count and maybe a little anecdote, but I've been at HashiCorp for about 4.5 years now. And on my first day, I sat down with my boss at the time, which was Armon. And we sat down in his office and we were talking about Terraform. And one of the things I said was, hey Armon, when are we going to get count on modules? So this is way back in sort of 2017. And Armon was like, oh, we're working on that. And we hope we'll have that later this summer. And he didn't actually say which year on which summer. He just said this summer, right? And it didn't turn up for another sort of 4 years. But there was a very good reason. I'm flippant and I joke about it, but the amount of engineering effort that went in to be able to deliver count on modules in 013 was huge. We had to get through that 2-year piece of development around HCL2, and then we had a couple of sort of minor iterations and then another sort of version after that. But count kind of is here now. Count and modules and some of the other parameters like the ability to specify which specific provider a module uses, they're all entrenched now in that 1.0 compatibility promise. And I think, Brian, you're gonna show us how some of this works.
So let's take a look at some syntax in order to get modules implemented. So with the Terraform registry And also, if you're on Terraform Cloud or Terraform Enterprise, you have the availability of your own private registry. You specify that source and also that version that we referred to. So as you can see here, we're saying an exact version. Also matching is that double equal. But in the absence of that, we're assuming that this is the exact version that we're going to match. Of course, we could still semver this. And what you could see here is that we're organized a little bit differently. We have this nomenclature of an organization, and then the module name and the provider that it is for. So in this particular case, organization being Terraform AWS modules, or in the case of your private registry, if you want your own, your company or your org identity, EKS is the module, and then AWS is the primary provider identified for this item. Now, with a private registry, app.terraform.io would be generally the defaulted location. If you're running Terraform Enterprise, that would be within your own organization, so you'll have your own custom URL. Now, of course, you could still do in repo or in path modules. And so historically, you would do / as a reference to where it is that I am currently, and then most people will put them into a directory like modules and then their own individual directory, EKS, for the EKS module in this example. You also have other interpolations. You have path.modules or path.root. These interpolations are still available to you in order to get to that. And then, of course, for module EKS under like a GitHub pull, as referred to earlier, it's really highly recommended that you reference some kind of a tag or branch. I prefer the tagging method. And so you can see there in a reference v17, etc. And that'll pull that exact version when it does that URL pull, or you can do a git SSH pull. Now, of course, there are many other methods and ways for you to be able to pull modules. And so I implore you, take a look at the documentation. There's a myriad of ways to get your modules both saved from things like Artifactory, etc. Now, overall, what makes a module a module? Well, module is nothing but a stamped version of Terraform code, and that is a full talk in and of itself as to what you would determine as an actual module. But generally speaking, a module is when you need to group a number of resources in a very explicit way, or you need to limit the myriad of options into some very specific use cases, and then you're telling your users this is the only way you can use this. Now, I'll also remind you, you definitely want to responsibly version your items, and hearkening back to semver, you want to make sure that if you're making breaking changes, you wait for the major version changes, your 1.x.x. If you're adding abilities, but not really changing a majority of your code, or simply adding features, that would be a minor patch or a minor version change. And then patches, of course, are just for bug fixes when you need to do things like fix docs, fix a syntax error, or things like that. And so that's when your patches would come in, which would be your last ternary there. But for every time when breakages must occur, and with those major version changes, you have a couple of options for you. You have Terraform state move, which is your CLI, in order to move a resource from one particular name to another, or to state remove, RM, to completely obliterate state from your items. A neat tool that I stumbled across, thanks to Nick, was TF migrate. TF migrate allows you to kind of codify those migrations. So you can kind of tell your user, hey, if you're using my module 2.0 and you're coming from 1. Whatever, run this script first, and you'll require TF migrate. And it will automatically handle all of your conversions, and we remove the things that we no longer need, we'll move the things that we need, and we'll inject the stuff that we need. It's a good way to do that. And last of which, of course, is Dependabot, which can also help you out with your modules and PRs to get into that. So I'd like to thank you for the journey down the yellow brick road. And this has been a fantastic event. Thank you.
Thanks very much. Thanks all for watching.